Well, welcome to the 4.6 Video D, Related Rates in Trigonometry. And we have a problem where a plane is flying horizontally toward a radar station at an altitude of 9,000 feet at a speed of 3,500 feet per minute. When the plane is 15,000 feet laterally from the radar station, how is the angle of elevation of an observer at the radar station to the plane changing? So the first thing we have to do is we have to identify what it is we have. And this 3,500 feet per minute is some dp dt. And we'll see, I might want to change that later depending on how this thing is going. Because if p, the distance from the plane to the radar station, is increasing, that should be a positive number. If it's decreasing, it's negative. And so we'll draw our picture and then fill that in later. We also want to know how an angle is changing. And so we're going to need d theta dt. And that's our unknown. And when do we want that? We're going to want that when the plane is 15,000 feet from the radar station. Okay, so here's our information, here's our unknown, and now we're going to have to draw a diagram. And so here's our airplane, here's our radar station, and we know that this is a constant 9,000 feet. So what are we actually looking for here? Well, we're given the speed of the plane, and so that's dp dt, and so that distance is getting smaller, but that means that this distance right here from where the plane is currently to the radar station, we're going to call that p. And I could have put it here, or I could have put it on top. It doesn't really matter. I'm going to put it down low because an angle of elevation is an angle from and then leading up. And so we wanted to know this angle, theta. Okay, so once we have our picture, now we're going to construct our relationship. If I have an angle, the opposite side and the adjacent side, oh, you know, that's tangent. And we're looking at 9,000 over p. Now it's time to take our derivative, keeping in mind that theta is a function of time because theta should be getting bigger and p is a function of time. P should be getting smaller. So let's go for this. And you know, I might do a little bit of housework before I take the derivative. I'm going to write this as tangent of theta is equal to 9,000 p to the negative first. And I hope that doesn't hurt anyone's feelings. Let's go for step 4 here, taking our derivative. So the derivative of tangent theta is 1 over cosine squared theta. But now I have to multiply that by the derivative, which is d theta dt. Awesome. Let's keep going. And on the other side, we'll have negative 9,000 times p to the negative second times, oh yeah, there's our derivative, dp dt. Now, what we're looking for is d theta dt, and we can solve for that very easily, just saying that d theta dt is equal to negative 9,000 cosine squared theta. I'll write this over p to the second times dp dt. And the dream is now to think about beginning to plug in and seeing what we have. So we'll go up. So what values can I use here? Well, we certainly have p equals that 15,000. So we have d theta dt is equal to negative 9,000 over 15,000 squared. We know that dp dt is that negative number. The only thing that we're missing here is cosine squared of theta. So I'm going to redraw our triangle at this instant in time. And we knew that we had, here was our theta. At the time we're looking, we had 9,000 as that side. We had 15,000 this side, and the question is, what is the cosine of theta? Well, if only I had the hypotenuse, I would have a fighting shot. Can we get it? Sure we can. Pythagorean theorem to the rescue. And so the hypotenuse here is 9,000 squared plus 15,000 squared, and I'll bang that out. And so we're looking at, oh my goodness, it's huge and ugly, but who cares? This is approximately 17,492.85. And I'm just going to let that thing ride like so. So if I let that thing go, we're going to have what? Cosine is equal to the adjacent side over the hypotenuse. And so I'll have 15,000 over the hypotenuse, 17,492.85. But it's not just one of these. We're going to have two of them because the value is squared. Okay, I've got a little bit of calculator work to do here, and then we can think about what this thing looks like. Well, friends, I finished it, and we got d theta dt equaling 0.129. And I want us to pause for a second and think about the units. Certainly the units are going to be per minute. But what about the numerator? Whenever we talk about a trigonometric function in the land of calculus, we are normally dealing with radians. Now, our gut check here. Does this make sense? And as we are super far away, the angle is going to only move a little. When the angle is when the plane is closer, it's going to be moving faster because we moved a little bit of distance, the angle is going to be more severe. So I'm going to say certainly we have a positive number, and yes, the angle shouldn't be that great because the distance from is bigger than the altitude of the plane. So sure.